We're going to work through a few examples of graphing using our connect the dots method. And so let's start with this first equation, y squared equals 2x. Of course, you should try to graph all of these three examples and then look at the solutions when you're done. For this one, we can write x, we can change this equation and solve for x in terms of y by dividing both sides by 2. And this gives us an equivalent equation and equivalent graphs. Every x and y which satisfy this equation satisfy the first one, and vice versa. So the graph of this equation is exactly the same as the graph of the equation on the left. Now, the advantage of having x written in terms of y means we can pick some values of y and then derive the unique x value that goes with them. So what I'm going to do is pick some points, some values of y around the origin, and then derive the x value that goes with them on the graph. There's a unique x for every y value on the graph, and that is y squared over 2, and then that'll give me a point on the graph. Then of course I'm going to join these dots to get some idea of what the graph looks like near y equals 0. So I'm going to look at a few points when y is minus 3, minus 2, minus 1, 0, 1, 2, and 3. And when y is minus 3, x is equal to minus 3 squared over 2, that's 9 over 2, which is 4.5. And we have our corresponding point on the graph here is x is 9 over 2. We have to be careful here which is the x and which is the y. When x is 9 over 2, x is 9 over 2 and y is minus 3. So when y is minus 3, x has to be 9 over 2. When y is minus 2, x must be y squared over 2. So we get x is equal to 4 over 2, which equals 2. So the point 2 minus 2 is on the graph. That is, y is minus 2 and x is 2. When y is minus 1, there's a unique x to go with it. That x is 1 over 2. And so the point, the corresponding point on the graph is 1/2 minus 1. When y is 0, x has to be 0, and therefore the origin 0, 0 is on the graph. And when y is 1, x is 1 over 2 again, so the point 1 over 2, 1 is on the graph. Now note that for any y value there's a unique x that goes with it, but for the x value 1/2, we have two possible y values that go with it. And that's because we can't solve for y uniquely in terms of x in this equation. Y would be plus or minus the square root of 2x. But we can solve for x uniquely in terms of y. And we'll discuss that later when we talk about functions. When y is 2, then x has to be 2 squared over 2. Is 4 over 2, and you see there's some symmetry here. That's 2. So we have the point 2, negative 2 is on the graph. Sorry, 2 plus 2 is on the graph. So we see here that when y is 2, x has to be 2, and also when y is negative 2, x has to be 2. When y is 3, then x has to be 9 over 2. And again, the point on the graph is 9 over 2, 3. Now we have a few points on the graph, and now they correspond to values of y near 0. And we've let y run from negative 3 to 3. Now we want to be careful about our units here. Our graph will extend to x equals 9 over 2, which is 4.5. So We should certainly allow room for that. And notice that all of the x values here are positive. So we have the point -3, 9 over 2. 9 over 2 is about here. This is on our graph. Negative, y is -2, x is 2. Y is -1, x is 1/2, is right here. And y is 0, x is 0. Y is 1, x equals 1/2 is here, and we see some symmetry here, which agrees with what we have noted here, that for the corresponding negative y value, you get the same value for x. And for y equals 2, we get x is 2, the point 2, 2 is on the graph, and also the point 9 over 2, 3. When y is 3, x is 9 over 2. And so we're going to join these dots here, and we get this nice parabola. And it looks like this. It opens to the right. Now, we assume that it keeps heading off in that direction, but that's something that we really need calculus to figure out what's going on. You should try the next equation, draw a graph, pick a few points, see what's happening, and sketch the graph of the equation, and then look at the next video to see the solution.